Today we're going to look at something different besides just wiring up something. This is going to be a little more substance to it. I've been talking to some coworkers, some guys out in the field, and it seems that people are asking questions about the X13 motor and a PSC motor and how to replace. Okay, so first and foremost, I don't recommend doing this necessarily. I want you to know that you should go back with OEM parts. That's like rule number one. Keep it simple. Replace what's supposed to be there with what's supposed to be there. But the X13 motor that we're going to be looking at today, way back when I first started out, I came across a motor that had more wires and no capacitor and stuff, and it was an X13 motor. So I looked up the website that was stamped on the bottom of it, and it was called thedealertoolbox.com. And I started watching videos after videos, just trying to learn about that motor because it wasn't taught in school. So but that's been years ago. Okay, and the X13 and some of the variable speeds that have come out since then, you know, they're kind of revolutionizing things, giving us better options, better power consumption, stuff like that. So anyway, what we're going to look at today, I've got an old air handler here. I pulled out the corner. It's got an X13 type motor in it. I'll show you that in just a second. But like I said, talking to coworkers and some of the guys out in the field, what we're going to do today is look at what it takes to replace an X13 with a PSC motor if you choose to. Okay, like I said, my little disclaimer, I recommend going back with the factory stuff, but occasionally, like we had one guy that we know, he had problem after problem with the X13s when they first came out. That circuit board and stuff inside was shorting out or whatever it was doing, but he finally just stopped replacing the motor and went with a PSC motor. So we're not going to look at changing a PSC motor to a variable speed, even though Genteq, and I think they've even changed their name. It used to be Regal Beloit, but now I think it's just Regal. So there's been some name changes there, but if you YouTube them, Google them, they got information galore. So we're going to take an X13 motor and put a PSC motor in it, in its place. Okay, so real simple control. So I just got an old air handler. It's got one heat strip, it's got a contactor, and it's got the X13 motor. So let me show you what we got real quick. All right. All right. So you can see here, I've got my two high voltage wires coming in. This is going to be our terminal block where power comes in, and also you know, the contactor for turning on our heat. So one single 5 kW heat strip, the heat relay / terminal block. Got my 24 volt connections there, and down here at the bottom, right down here at the bottom is the X13. All right. Now, X13 motor, with a PSC motor, we typically have a relay that has a 24 volt coil that closes a switch to move the high voltage, which is a lot different than this X13 motor. The X13 motor, one thing that I learned way back when, like I said, when I looked up the dealer toolbox, is this motor and the variable speeds along with it, they have high voltage all the time. If the power's on, they got high voltage. They rely on a low voltage signal to that module to turn it on. Okay, so here we've got two low voltage signals, one for heat, one for cool. Okay, and that's what actually is the final step to turn that motor on, or at least that's how I'm going to describe it. That's the way I think. So and then we've got another plug here where you've got your 24 common, you've got your ground, L1, L2, L1 and neutral, what have you. Okay, so it's this block. Okay, usually it's two plugs, but it can be individual wires and terminals. But it's basically two rows. You've got basically a high voltage and a low voltage set of terminals, and that's what we're going to look at doing today. Is replacing this. Replacing that. Forgot to turn the power off. We're going to change all this out with a PSC motor. So hopefully this makes sense. I always like thinking about stuff. Electricity is one of those good things. It's always a brain game. So we're going to replace this motor. I'm going to pull it out and swap out that belly band and X13 with a PSC motor. So hang tight and let me get that done. All right, so here's a little bit better, or hopefully a little bit better shot. You'll see that even though this is not the X13 stamped on the end of it from Genteq, it is still a I guess I could say knockoff, but I can identify it because it's got the 1, 2, 3, 4, 5, okay, which is going to be my low voltage terminals, and this second row back here is going to be my 24 common and my L1 neutral and ground, or L1, L2 and ground. Okay, so like I said, this two-row setup, whether it's a plug or individual wires, I've seen both between Lennox, Carrier, Bryant, Payne. I've seen them both, but you have to be able to identify, or at least try to identify, what you got. So this motor, the X13, has no capacitor. It's all built into this module that's on the tail end of the motor, of course opposite the shaft. But I mean, they're real simple motors, but they're more efficient electrically and stuff. But in the beginning, they also had some problems. So because of this, we get into a little bit of wiring. Like I said, this motor is always powered by high voltage. We're waiting for a signal, and in this case, we had a blue wire on number 2 and a white wire on number 4. So the 24-volt signal on 2, which is it's not a speed tap. It's not like high, medium, and low. It's more or less it's a constant torque motor, if I coin the term or use the term properly. So it's not a variable speed where you set the CFM. That's kind of already been done, but it's a constant torque that this motor is going to do. So that speed tap, some taps may not always be programmed. So just because you have 5 speed taps or torque taps, don't mean that you're going to be able to use all 5. You may only be able to use the 2 and the 4 in this case, because that's what's programmed from the factory or from the dealer. Okay, so anyway, this poses a little bit of a problem because we've got 2 high voltage wires that we got to do something with, and that's what we're going to look at now. We have to change this, not to run 24 volts down to it anymore. We're going to actually use a 9340 relay to do that. So I'll try to keep it as short as I can, and let's get to it. All right, so this is a hack job, but it is what it is for the sake of learning. Okay, so what I'm going to do is cut loose some of these wire ties that were holding all these wires together, and try to walk you through as best I can. So the blue and the white, okay, for the Carrier, Bryant type family like we have here, the Payne, there's a gray wire in your low voltage connections up in this upper corner of where the top would be, and you can see here that they basically put a resistor and stuff in, and it's connected to the blue wire. So I'm going to use that. Just so you know, this is what they were using to give the 24 volts when the G got powered, and because all the white wires are connected, when I got a signal for heat, then it goes in here to this group of wires, and that white wire comes out of that. Okay, we're no longer going to need that. We're going to need just a 24 volt signal. So what I'm going to do is get rid of this, and we're just going to use what we need to. Okay, so we don't need the extra white wire, so I'm going to get it out the way. All right, use it for another project later. I really don't need the blue wire, but I'm going to use it to give 24 volts for green. Okay, these other wires here, okay, if you read the plug, of course we got our green with our white stripe, that's ground. Okay, and I've also got, I mean, they write it right on the plug. The brown is your 24 common, so it's got a C. The black is your L1, and the yellow is your L2 in this case. All right, so I don't need any of these really, because I'm not sending high voltage power to this PSC motor like we did the X13. The PSC motor, okay, I've got a yellow for one side of power, and I've got basically my 3 speeds, high, medium, and low, black, blue, and red. Okay, so we're going to go ahead and put in a 9340 relay right here next to this heat relay or this heat contactor, and we're going to wire it up. Unfortunately, like I said, to do this in the field is a hack job because you don't need most of those wires. All right, so bear with me. I'm going to run through this real quick and try to explain it, but I don't want to do 10 minutes of just crazy YouTube stuff. So let me get this prettied up and I'll show you what we got. All right, total hack job. I cut the high voltage plug going to that X13 motor. I just cut it all out because we don't need it anymore. And I also took the low voltage out going to that second set of plugs, or second plug on that motor as well. All right, so we'll use those for extra wires. So what we're going to do is, since I cut out the gray wire and the blue wire that was going to torque tap number 2, I'm going to use this as my new green. I've taken that plate out the corner so we get a little better shot maybe. But I've got red, I've got this wire I'm going to use for my green, I've got my white that went down to the motor as well. So we still have our basic controls as far as low voltage. The only thing now is, just like the high voltage speed taps on this PSC motor, and I've got the capacitor and everything down here below, we're going to have to put in this 9340 relay, okay, to control it. So it's a real simple relay. I've done a little bit of stuff on this. I try to speak right, but the 9340 relay, double pole, double throw. I think I messed that up on somebody's comment, but it's a general purpose relay. It's awesome. So 24 volts are going to go here at the bottom, and then we're going to use the common, normally closed, and normally open speed taps. That way we make sure the fan works by itself, and we also make sure that the fan works when the heat comes on, okay? So we'll wire all that in and show you how we do it. So let me mount this up, and I'm going to cut this wire for the G circuit appropriately, and then we'll get to wiring and do a couple voltage checks maybe. So hang tight. Now on this heat contactor, the orange is my common. So what I'm going to do is I'm going to take and create a jumper wire just to save some space, right? Common on this 9340 relay, and just a little jumper over here to this other little rabbit ear connection on the side of that contactor coil. And that'll pick up the common there, bring it back, and save us a wire and a wire nut. All right, there goes our common connection. All right, and what I'm going to do here is, I tried to find a green wire honestly, but I don't have one in my little scraps. So I'm going to use that there. That'll be my G connection. Okay. And I think now I'm going to take you up top so you get a bird's eye view. Maybe it'll make a little more sense. All right, so hang tight for that one. All right, so here we go. We got the common down here on the 9340 relay coil. We got our hot side that we're going to use the G circuit to power, okay? And now we're going to look at this common, normally closed, and normally open switch, or 1, 2, and 3, okay? So I'm going to run the wires for my PSC motor. I'm going to run them up through this little hole here, all right? So, real simple, the yellow, which is the other side of power for this motor, I'm going to put over here on the yellow side, right? So we're going to snake that up underneath, and I'm going to plug it in right here with all the other yellows. Alright. Now on the 9340 relay, when you're using it, since we have a PSC motor, you can only energize one speed at a time. And on this air handler and like the Goodman air handlers, the easiest thing to remember is you've got heat and cool, two ways to turn the fan on, but only one speed you're going to use. So we're going to use this number 2 and 3, or normally closed and normally open side of the switch. We're going to use that as power in, okay? And then we're going to use the common, since that's common to both switches, we're going to use that as power out. So that number 1, or that common, as the Goodman board would have it, that's where I'm going to put my speed that I'm going to use, okay? And now what we have to do is we have to bring power in to number 3 and number 2. Number 3 will get straight power from L1, and then the number 2 we're going to have to pull off of the load side of our heat relay, and when the heat strip comes on, it will feed power into the normally closed to bring the fan on. Okay, so hang tight, let me get that wire and we'll put it on. Alright, here we go. So we've got the common, we've got the 24 volt hot, the G, and we're going to hook up the high voltage now. So this contactor that we're using as a heat relay, okay, the orange is the common, so we got that there. But let's look at the yellow and the black, okay? So they're kind of color coded, L1, L2. I don't get mixed up on the L1, L2. I just call it line, you know, and the other line, right? One side of power and the other one. So I know that this yellow is my other side of power as we speak. So I'm going to focus on just this switched side of the contactor, since this is a single pole, just this right side as you're looking at it, the side with the black wires. The speed is on the common going to the PSC motor. So what I'm going to do is I'm going to pull power off of the line side of this terminal block contactor, and I'm going to put it on terminal 3, or the normally open one. And this way, when I energize the coil, the switch between 3 and 1 will close, and this L1 power will pass across and go to the high speed. Okay? To make sure that it runs with heat, okay, now I'm going to use a yellow wire just so you can see the, you know, the differences in the color. I'm going to come off of the load side, because when the heat comes on, I need to have the fan on. So I'm going to pull off the load side of that same power, and I'm going to go to the normally closed, okay? And this way, when the heat strip gets power, at the same time it passes power to my blower, okay? And we keep the same L1 going back to the L2, okay? Or one side of power and the other one. So each leg is 120. We have a 208 system in the shop, so you know, it gets a little weird with some people, but it's 240 at a house. So 120 on L1 and 120 on L2, you get 240 volts. I'm not going into the whole alternating current or everything, but just so I try to speak a little more proper, right? Anyway, so we've got L1 uninterrupted power going to the normally open, and we have L1 power after the heat sequencer, contactor, relay, whatever it is, after the switch. One's on the line side of power of the terminal block or relay, and one's on the load side getting power. It's the same leg of power, right? L1 and L1, but it's just after the switch or before the switch, okay? So let's turn it on. We'll do some voltage checks and be done with it. All right, so let's see, we got our meter here. Of course, the heat strip's not working. We've got no amps on the heater. I'm gonna check this blower leg here, and I've got no amps on it as well. Okay, so nothing's running, but of course I don't have the thermostat or the low voltage telling anything to run. So let's make some stuff work. All right, it gets a little crowded in here trying to put the meters and stuff, but I've got a amp meter here on the high. We're only going to use the high speed because we don't have a board like Goodman. All I've done is I've isolated the medium and the low speed and just put a piece of tape on them just to show you. But the high speed is there. What I'm going to do over here in the corner, all right, sorry about that, right? I'm going to connect my hot to my green wire, my 24G, all right, and you should hear the fan relay click. Hey, look at that, 1.94 amps. Okay. Relays are instant, where circuit boards can have time delays. So there's my 24 volt. Okay, and I can also do the same thing with the white wire to make sure that we actually have a good properly wired circuit through the normally closed. So here's for the heat strips. And since the contactor is instant too, then we get the heat strip and the fan. So we'll do a couple voltage checks, but everything works fine. I didn't see how many amps that was pulling. Yeah, about the same. Okay, so what I'll do now is I'm going to pan the camera back a little bit. I'm going to swap this out for low speed, and we'll do a couple voltage checks just as good measure. All right, so sit tight.